In this video, we are going to look at the difference between a prime number and a composite number, and then we are going to look at some number sets to be able to answer some questions on that. Um, so the first thing is a prime number is a number that can only be divided by itself or the number 1. So for example, the number 5. I cannot divide 5 by anything else and get a whole number except the number 5 itself or the number 1. So 5 is a prime number because I cannot divide it by anything other than itself or 1 to get a whole number. Okay. A composite number is a number that can be divided by a number other than 1 or itself. So for example, the number 4, I can divide by 2 and get a whole number. So 4 is a composite number. All right, as we go along, I'm going to show you also a few other ways to check, some easy checks that you can do to see if a number is prime or composite. All right, so we're going to start with our first number set, and that number set is 13, 97, 27, and 61. And our question is, which of the following is not a prime number? So if it's not a prime number, it's a composite. So which is composite? All right. Now, one of the first things that we want to do when we're trying to find out if a number is prime or composite is we want to see if the number is even or odd. Remember, an even number is any number that ends in 0, 2, 4, 6, or 8. And then an odd number, if you'll remember, is any number that ends in 1, 3, 5, 7, or 9. All right, so the first thing we want to check and see is it even an even number? Because the only even number that's prime is the number 2. Every other even number, well, I guess 0 would count as well. 0 and 2 are the only ones. Every other even number we can divide by 2, and so it's composite, other than 0 and 2. So looking at my number set here, I've got 13, well that's an odd number because it ends in a 3. 97, that's an odd number because it ends in a 7. 27, that's an odd number because it ends in a 7. And 61, that's an odd number because it ends in a 1. So that particular check won't work. That doesn't help me one way or the other. All right. So one other thing we can look at is the number is it divisible, or can I divide it by 5? And the way I know I can divide a number by 5 is if it ends in 0 or 5. Any number that ends in 0 or 5, I can always divide by 5. All right. Once again, though, that doesn't really help us with this particular number set. So now we've got to do a little bit of work. So my first two checks, the first thing I want to always do, is it even and does it end in a 5? That will give me a really quick answer and I won't have to do a lot of computation. But for this, unfortunately, I'm going to have to do some computation. Now, the next thing we can look at is, are any of these numbers familiar? And what I mean by that is, are any of these numbers familiar when it comes to our multiplication facts? Do we have numbers that we know we can multiply together to get 13, to get 97, to get 27, to get 61? Now, if you know, if one of those jumps out at you, then you'll know, hey, that's the one I need to select. But if you don't, if a number doesn't jump out at you, then the next step that you want to take is you want to divide them by 3. Okay? Sorry, my glare is keeping you from seeing the division symbol. Let me change the spot. Let's divide by 3. All right, so 13 divided by 3. Well, that's not going to work because if I do 4, I'm going to get a remainder. So that won't, so 13 won't work for 3. All right, let's try 97. Okay, so again, I'm getting a remainder, so that's not going to work. All right, let's try 27. 27, that number seems familiar, especially when I'm thinking about 3. How many times does 3 go into 27? Hey, wait a minute. Is it 9 times 3, 27? It is. Which means that this is a composite number, because I can divide it by 3, which is not itself or 1, and get a whole number. All right, let's go ahead and do 61 just to complete the process, just to make sure I haven't made a mistake here. So 61 divided by 3. And so again, I'm going to end up with a remainder, so that doesn't work. So my answer for this first problem would be 27. I know 27 is composite because I can multiply 9 times 3. Okay? All right, let's go on to number 2. And number 2 is going to be a little bit different because not only are we going to figure out if it's prime or composite, we're also going to throw in, is it even or odd? All right, so our number set on number 2 is 71, 55, 83, and 37. And the question is, which one of these is an odd composite number? So which one is an odd composite number? Now, if I look at these, they're all odd because they're all ending in 1, 3, 5, 7, or 9. So here's 1, here's 5, here's 3, here's 7. Okay, so all of these are odd. All right, so every single one is odd. So I don't really even have to worry about this right now because I've already checked it and they're all odd. So which one is composite? Well, let's go through our quick check. So are any of them even? Well, no, we just said they're all odd, so I can skip that first step. So my next step is, do any of them end in 5? Ooh, what about 55? Well, we just said that if it ends in 5, then it should be a multiple of 5. So let's divide 55 by 5 and see if it actually is a multiple. And it is. So what that tells me is 11 times 5 gives me 55, and so 55 is a composite number. That also just happens to be odd. Okay, let's do one more. And this question is going to be a little bit different than the first two. It's going to require us to think a little more. But our number set is 7, 10, 42, and 15. And the question asks, which of the following number has only 2 factors? So only 2 factors. I better put that only there. Only two factors. All right, so looking through this, right off the bat, well, let's just go through it. All right, so what are my factors of 7? Well, I think 7 can only be divided by itself or 1. All right, let's go on to 10. So that doesn't really count. This can only be divided by 5 or 2. 15 can only be divided by 5 or 3. 42, 2, 21, 7, 3. All right, so it looks like this question is counting the actual number and 1 as one of the factors. So because of that, what I originally mistakenly said was wrong was actually my right answer. So the problem is counting 7 and 1 as the factors. So with 10, I've got 10, the number itself, and 1, and 5 and 2. So that's 4 factors. 42, I've got 1, 2, 3, 4, 5. I've got 6 on that one. 15, I've got 4, and 7, I only have 2. So the number's really asking for which one is prime. That's really what it's asking. All right. So remember, the difference between a prime number and a composite number. A prime number can only be divided by itself, or 1, to get a whole number, and a composite number can be divided by another number other than itself, or 1, and get a whole number.